In this section, we are going to be discussing environment, atmospheric, and volumetric effects in V-Ray, and in this lesson particularly, we'll be taking a look at environment fog. V-Ray environment fog is an atmospheric effect that simulates fog, haze, atmospheric dust, and other atmospheric aerosols. The scene I have here is from the volume 30 of the ARC Exterior Collection by Evermotion. We are gonna spend a very small amount of time here to explain how to set up environment fog, and then we'll be headed to our next scene to explain different parameters of this effect. The current scene won't be provided with the project files, and if you like it, you can head over to evermotion.org and buy the scene. To add environment fog to your scene, simply from the rendering menu, go to the environment window, come down, and from the atmosphere section, click on this add button and add environment fog. And if you select the environment fog itself, you can see and adjust all of its parameters. The first parameters I want you to look at are fog distance and fog height. Fog distance controls the fog density. Larger values make the fog more transparent, while smaller values make it more dense. And fog height, as the fog is supposed to start from a certain Z level height and continue downward indefinitely, this parameter determines the starting point along the Z axis. I know that 100 centimeter for the fog distance is gonna give us a very dense environment fog for this scene. So let me increase it to something like 5,000 centimeters so we get a more transparent fog. And for the fog height, I know the house we have in the scene is about 8 meters and we have these huge trees. Let's use a height of something like 10,000 centimeters. Now if I go to the frame buffer, the first render was done without environment fog, and as you can see we get a clear image. And in the second render, environment fog was active with the current settings that we have. Maybe the fog effect is a bit exaggerated, but we can make the fog more transparent by increasing the fog distance even more. Let's set the fog distance to 10,000 centimeters and see what we get. And as you can see, compared to our previous render with the fog distance of 5,000 centimeters, we get a more transparent fog. In the next render, fog distance was set to 20,000. Again, more transparent fog, and in the next render it was set to 50,000. And if you compare this final render to our first render with the fog distance set to 5,000 centimeters, we get a huge difference and obviously less dense fog. And here is our final render with full HD resolution with fog distance set to 5,000 centimeters. Let's just apply some quick color corrections. Enable exposure and set the exposure to something like 0.7. Enable white balance and set it to something like 8,000 so we get a warmer render. Enable color balance and make the shadows a bit cooler, maybe something like 0.14, and the highlights all the way to the yellow side. And this can be our final render. Now let's open up the specific scene for this lesson and start going through all the environment fog parameters. In this scene, which is 0901 environment fog start, we have this very simple scene. We have this box as our main subject, a main light that is coming from the right side, and a secondary light that is coming from the left side. And if we render the scene right now, this is what we are going to get in render 01. Now let's go to the environment and effects window and add V-Ray environment fog. Now if we render the scene without changing anything else, this is what we are gonna get in render 02. And obviously we are going to get our environment fog effect, right? The first parameter I want to talk about is fog height, and we know fog height is the point where the fog starts on the z-axis and continues downward indefinitely. The box we have in the scene is 30 centimeters on each side, so if we decrease the fog height to something like 10 centimeters and also decrease the fog distance to something like 30 centimeters, so we get a denser fog, and render the scene, we get render 0, 3. And now we can see where the fog actually starts, which is 10 centimeter point along the z-axis. Let's get back to the environment and effects window. Set the fog distance and fog height to 100 centimeters, which is their default value. To discuss the rest of the parameters, what I want to do is to confine the fog effect to be only visible inside this box. And to do so, what we can do is to come down and add the box to this gizmos list. So let's click on this add button, press H and select the box. Now we need to hide the box in the Explorer to be able to actually see the fog effect. Let's hide that. Now the environment fog effect will only be visible inside this box, and as you can see, the fog height parameter is grayed out, and wherever the box is, the fog effect will be in there. Also, let me decrease the fog distance to something like 5 centimeters so the fog would be more dense inside the box. And if we render the scene right now, we are going to get render 0, 3. The first parameter we have is the fog color, and this is the color of the fog. Obviously we can use a simple color or use a texture. Down here in the maps we're allowed to control the color of the fog. Let's change the color to a color like 38, 217 and 190. Render the scene, and we're going to get render 04, in which the fog color is this turquoise color. Or we can use a texture to control the fog color. So let's open up the material editor. And create a gradient ramp map. Change the first color to a pinkish color like 210, 30, and 174. For the second color, we can use a turquoise color again, like 10, 115, and 127. And for the third color, let's use a yellow color like 231, 255, and 24. Also, let's make sure the mapping type is set to planner from object XYZ. Now we can use this map as the fog color map. Okay. And if we render the scene right now, we're gonna get render 05, and as you can see, the gradient map has been applied to the fog color. Let me disable fog color map for now and change the fog color back to its default color, which is a white color with a value of 217, and press OK. We discussed fog distance. We have fog emission, and this option controls the fog emission or self-illumination. Obviously, if we render the scene with fog emission color set to black, we don't get any self-illumination from the fog, as we can see in the frame buffer. Now, first let's try a medium gray color as the fog emission color and render the scene. As you can see in this render, we get a visible self-illumination quality in the fog. And for the next render, let's set the fog emission color to an orange color with the R, G, and B values set to 188, 109, and 52. And right now, the self-illumination property has an orange hue. Let's set the fog emission back to black for now. We have scattered GI and scatter bounces. Scattered GI, when enabled, the fog will also scatter global illumination. This can obviously slow down the render in more complex scenes, and in most cases we can use fog emission color instead of the scattered GI option and get quite similar results without that much increase in render time. And scatter bounces controls the number of GI bounces inside the fog when scattered GI is enabled. In the first render, scattered GI is off. Now we can enable scatter GI and set the scatter bounces to 1, and this is going to be our render. And in the next render, scatter bounces was set to 4, and as we have more GI bounces here, the fog looks brighter obviously. In this case, let's leave the scatter GI enabled and set the scatter bounces to 1. Then we have subdivs, and when you don't use any textures in the maps rollout to control fog color, fog density, or fog emission, subdivs controls the overall quality of the fog effect and basically determines the number of points inside the fog at which volumetric lighting is evaluated. Smaller values for this parameter render faster but may produce noise in the image. Higher values render longer but with less noise, and obviously image sampling is going to affect this volume. Now what I want to do is to enable the fog color texture again and control the fog density parameter with a simple checker pattern. So in the material editor, add a checker texture, set its mapping to planar from object XYZ, and its styling to 5 and 5. Now we can use this checker as the fog density texture. Also, let me set the fog density to something like 2 centimeters so we get a more dense fog effect, and if we render the scene, we are going to get render 0.6. When we actually use a texture to control fog color, fog density, or fog emission, the overall quality of the effect will be controlled using step size, texture samples, cutoff thresholds, and max steps parameter. And let me quickly quote V-Ray's guide on these parameters. Ray matching sampler is used when any of the fog properties like color, density, or emission is mapped with a 3D texture. The sampler steps through the volume, evaluating volumetric textures and lighting until it leaves the volume if there are atmospheric gizmos specified, or until the accumulated volume transparency falls below a certain cutoff threshold, or until a specified number of maximum steps is reached. Step size determines the size of one step through the volume. Smaller steps produce more accurate results but are slower to render. In general, dense volumes require smaller step sizes than more transparent volumes. In practice, step sizes that are 2 to 3 times smaller than the fog distance parameter work well. We have texture samples, which determines the number of texture samples for each step through the volume. This allows to sample textures more accurately than the volumetric lighting. It is useful in cases where the texture vary much faster than the lighting itself. And cutoff threshold controls when the ray matcher will stop calculating the volume. If the accumulated volume transparency falls below this threshold, the volume will be considered opaque and tracing will be aborted. Higher values make the rendering faster but may introduce artifacts. And max steps specifies the maximum number of steps through the volume. Let's set the step size to 16 and take a look at the frame buffer. As you can see, with the step size of 16, we get a very noisy and inaccurate result. The step size of 4 was used in the next render, and we get more accurate result, but still there are some problems in the shading, as you can see. We already know that values for the step size that are 2 to 3 times smaller than the fog distance parameter work okay in most cases. The fog distance is set to 2 centimeters right now, so a step size of 1 or 0.5 centimeters should give a more accurate result. So in the next render, step size was set to 1, and the result is much better and the shading is more accurate, but if I zoom in, we still get some shading problems. And finally, step size was set to 0.5 centimeters, and this value gives us perfect results. We have gizmo fall-off radius, When this value is larger than 0 and the fog effect is contained within a gizmo like the box object that we have here, this option allows you to specify a fall-off radius for it. This way the fog effect does not have sharp edges at the edges of the gizmo. In the first render, fall-off radius was set to 0 and we get our normal render with sharp edges. In the second render, fall-off radius was set to 20 and now the edges are becoming more transparent. And finally, fall-off radius was set to 20. Now let's set the fall-off radius to 0 again. We have Gizmo fall-off mode, which allows you to choose between two different fall-off modes, multiply by density and add density to fall-off. We have Gizmo merge mode, which specifies how overlapping gizmos are rendered, either overlap or blend. If you just unhide the box and shift and drag it to have a copy, me set the exposition of the second box to 17 centimeters. Now let's add the second box to the gizmos list and now hide both of the boxes. Now if you render the scene right now, the first render here in which merge mode was set to overlap, and in the second render it was set to blend. You can see just a bit different in this overlapping areas. Let's set it to overlap again. Deep output, if enabled, allows for deep EXR output of the fog effects. We have maps rollout that we discussed. In the ray filter section, you can determine what rays are affected by the environment fog effect. Affect background. When disabled, the background will not be obscured by the fog. Affect reflection specifies whether the fog will be rendered in reflections or not. Affect refraction specifies whether the fog will be rendered in refractions or not. Affect shadow specifies if the fog should affect shadow rays, and affect GI specifies if the fog should affect GI rays, and affect camera rays specifies if the fog will be visible to the camera rays. In the nodes rollout, we have two lists. In the gizmos list, we can add as many objects as we want, and the fog effect will be confined within those objects. Make sure to hide those objects that you add to this list, or make them not renderable to see the fog effect. In this case, let me remove box 002 from the list. And if this list is empty, we get the fog effect in the entire scene based on the fog height parameter. On the right side, use all lights is enabled, so all the lights in the scene will affect the environment fog right now. I can disable this option and pick only those lights that I want to affect the environment fog. So click on this add button, press H and select only the main light. In the frame buffer, the first render was done with use all the lights enabled. So here we are using both the main and the fill light. And in the second render, we are only using the main light to affect the environment fog. As you can see, the left side is getting a bit darker. Now let me remove the main light from the light list and enable use all lights again. For the final render, let's create a quick 3D checker pattern. So open up the material editor, shift drag to copy the current checker pattern and rotate it on X by 90 degrees. Let me add a new composite map. Connect the first checker pattern to layer 1 and the second one to layer 2, and set the blending mode to for the second layer to multiply. Now if we connect the composite map to the fog density, we are gonna get a 3D checker pattern in the fog effect. Now let's take a look at a few final renders. This is our first final render. Now let me go to the denoiser pass. And here the original texture pattern was used. In the next render, the composite of the two checker pattern was used and we get this 3D checker pattern. And in the next render, I changed the black color in the checker maps to a medium gray. And you can see the result in the frame buffer. Now I invite you to go ahead and try different maps for fog color and fog density and have some fun on your own. So in this lesson we learned about environment fog, and I will see you in the next lesson.